Gracias. 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 Estoy muy feliz de estar aquí en ese muy lindo país de Chile, en esta muy linda ciudad de Santiago también. Es un gran privilegio para dar esta charla magistral esta mañana y ahora voy a cambiar en inglés. Abre tus ojos y un mundo aparecerá. Open your eyes and a world appears. Now this seems like the most natural thing ever. It seems as though your eyes, all your senses are windows onto a beautiful world full of objects and people and places. It really seems as though there's a world out there with things like mountains and oceans and rocks. This is a photo from the Magallanes region in Patagonia where we were lucky enough to visit just a couple of days ago, just yesterday. So it really seems that this world is out there and our eyes and our senses are providing a window onto it. And then there's the experience of being a self, the specific experience of being yourself. You don't even have to open your eyes for this. It just happens. Now, this all seems very obvious, right? There's a world out there which is detected by each of us through our senses, through the self. And that forms perceptions of this external reality. That's how things seem. The world, we sense it, the self senses it, we form perceptions of that world. Maybe that's how you would say it in Spanish. How things seem, though, is, of course, often a very poor guide to how they actually are. Now, many, many years ago, Copernicus pointed out that although it seems as though the sun rotates around the Earth, of course, it's the other way around. The Earth rotates around the sun, and in fact, the whole solar system is rotating around the center of the galaxy, and of course, there's dark matter. In any case, things are not as they seem. Now, I'm not an astronomer, I'm a neuroscientist, and my job as a neuroscientist is to try to understand how this 3-pound tofu-textured meat machine in between our ears gives rise to an inner universe, the inner universe of our experience of the world around us and of ourselves within it. Somehow, within each of our brains, the combined activity of many billions of neurons, about 89, 90 billion neurons, is giving rise to a conscious experience. And not just any conscious experience, your conscious experience right here and right now. How does this happen? So in the story I want to tell you today, our conscious experiences of the world around us and of ourselves within it are kinds of controlled hallucinations generated by the brain and designed by evolution to help us keep alive. And I should say right at the beginning, I'm not saying that the whole world out there is an illusion, that it doesn't exist. No, I'm saying that our experiences of it, our constructions, are generated, are not direct reflections of an external reality. They're hallucinations that happen, controlled hallucinations that happen with, through, and because of our living bodies. Alucinaciones controladas, puede ser. Now, in telling this story, I want to pay tribute right at the beginning to one of my intellectual heroes, the Chilean neuroscientist Francisco Varela. When I was studying my PhD, Francisco Varela was pioneering the area that he called neurophenomenology. And this is an approach to studying consciousness that I just thought was really the right way to do it, to think about brain mechanisms, to think about experience, and to try to just see how they related in a way that took our experiences very seriously. So he was a great inspiration to me. I know he's been a great inspiration to many of my colleagues in neuroscience. And he passed away, sadly, quite young, quite a few years ago now. I never met him. I always wish I had. But I have the feeling that I've been always just following in the footsteps of Varela throughout my career. But also in my career, I've had the great fortune to meet a number of brilliant neuroscientists from Chile. So being here today is not only a personal privilege, it's a scientific privilege as well. Let's get back to the world around us and to consciousness. And let's start very simply by thinking about our experiences of the world, and let's get even simpler by thinking about just how we perceive the world through vision. So our eyes do open our brains to the world, but the photoreceptors in our retinas are sensitive to only a very small range of the electromagnetic spectrum. Now, this thin slice of reality, that's where we live visually. But even within this thin slice, things are not as they seem. So here's the first test for everybody here. What I want you to do is pick one of these screens and just focus your eyes on the black cross in the middle. Try not to move your eyes, try not to blink. And after a while, if this is working, and what I'd like you to do is just raise your hand if it's working for you. If you start to see just a green patch moving around, then raise your hand. Is everybody getting it? Pretty much, that's excellent. Well done. Now, blink and move your eyes, and the magenta patches should come back. Yeah? So there is no green disk. There is no green disk there. There are only magenta patches that are turning on and off one after the other. So things are not as they seem at all. How do we understand this? Well, the basic idea for today is that your brain is a prediction machine. El cerebro es una máquina de predicción. What you see, hear, and feel are nothing more than the brain's best guesses of the causes of its sensory inputs. So just imagine being a brain. There you are, you're locked inside a bony skull trying to figure out what's out there in the world. Now, there's no light in the skull, there's no sound in the skull. All you've got to go on as a brain are streams of electrical impulses which are only indirectly related to things in the world, whatever they may be. These signals don't come with labels like I'm from a cat or I'm from a beer or I'm from a coffee cup. They don't even come with labels like I'm from the eyes or I'm from the ears or I'm from the heart. So perception has to be a process of informed guesswork in which the brain combines these sensory signals with its prior expectations, predictions, or beliefs about the way the world is to form its best guess about what caused those sensory signals. And that's what we consciously perceive. The brain doesn't hear sounds or see light. What we perceive is the brain's best guess of what's out there. Let me give you a couple of examples of this, and you may have seen these examples before, but I think they work quite well just to illustrate this general idea. This is something called Adelson's checkerboard. And if you look at the two patches A and B, hopefully they look to you to be different shades of gray. Does everybody see them as different shades of gray? Yeah, well, mostly it should seem different. They are, of course, the exact same shade of gray, and I can demonstrate this if I just put a different version of this up next to it. Is this going to work? So those are the patches. And now you can see in the second one, I've joined them together, and you'll see that it's a continuous gray color. There's no difference. So it's, in fact, A and B are exactly the same shade of gray. If you think I'm messing around, if I'm tricking you, well, I'll just move this bar across, and you can see there's no trickery. It's a continuous shade of gray. That's what's actually there. If I take the bar away, it looks different again. So what's going on here is the brain is using its prior knowledge built deep into the circuits of the visual cortex that a shadow dims the appearance of things. So then we will see B as lighter than it really is because it's in shadow. Here's another example which just shows how quickly the brain can use new predictions to change your conscious experience of what's out there. This is a so-called Moony Image. And if you haven't seen it before, then probably what you see here is just some random pattern of black and white marks with no particular structure. But if I now fill them in with an image, you'll see there's actually something going on there. There's a horse, there's a woman wearing a hat, the woman is kissing the horse for some reason. There's something going on. Now, if you look at that image for a little while, I won't leave it up there for too long because we don't have too much time, but I leave it there for a little while, take it away, and now you should still be able to see those objects in this image. This was the first image that I showed you, where previously there were just random patches. Now there's something going on and something is happening. And what's remarkable here is that the sensory information coming into your brain hasn't changed at all. All that's changed is your brain's best guess of what caused that, and that changes what you consciously see. Now, thinking about perception this way dramatically changes how we might think how the brain accomplishes this feat of perception. Now, the intuitive way to think about perception is that sensory signals from the world enter through the retina and then get deeper and deeper into the brain, and as they get further in, they get processed in more complex ways. So, for instance, earlier parts of the visual brain might deal with things like orientation, or luminance, how bright something is, while higher and deeper levels of the brain might deal with more complex features like faces. And this is a monkey brain, so this is a monkey face. But in this picture, all the heavy lifting, all the hard work of perception is done by signals coming from the outside in, or from the bottom up. Now, the prediction machine view of perception changes this around completely. Instead of perception depending mainly on sensory signals coming into the brain from the outside, from the sensory organs, it depends just as much, if not more, on perceptual predictions flowing in the other direction. The world we experience comes as much, if not more, from the inside out as from the outside in. And if you think about it, this is a little bit like what Copernicus said about the solar system. It seems to us that perception is this process of a reading out of sensory information that's coming from the world. But in fact, it's the other way around. We are projecting our perceptions, testing them against the court of reality. So I want to get just a little bit more in detail about what this means. And this is definitely the most complicated slide I'm going to use. And you don't have to worry about the details at all. I'll just tell you the important points. But this gives us an idea of how this process might actually be accomplished in the brain. And it's not accepted by everyone, but I like it. So this is a picture of what's called predictive coding in the cortex. And the basic idea is that top-down connections that go from the inside out, the blue arrows in this picture, carry the brain's predictions about sensory signals. And the red arrows, which come from the bottom up or the outside in, these are the arrows we normally think of as carrying sensory information about the world. No, they just carry the difference between what the brain expects and what it gets at every level. They carry what we call the prediction errors that the brain is continually trying to resolve. So perception, this process of neural best guessing, is implemented in the brain by it simply trying to minimize these prediction errors everywhere and all the time. Perception isn't about reading out sensory information. It's about calibrating the brain's current best guess against an unknown and ultimately an unknowable reality. And one implication of this is that what we consciously see is going to be deeply shaped by our expectations at any given time. And we all know this in some way. If you walk out of your house on a misty morning, if you have misty mornings in Santiago, and you're expecting to meet a friend, you might really see your friend to be there until you get close and realize that it's a stranger. But you saw your friend because you're expecting to see them. And of course, these expectations are not things you might have to have at a very high level, like, I think I'm going to meet my friend. They might be very low level, like the expectation that things in shadows are darker. But this is what's happening at all levels of perception. And here's a very simple study that we did in our lab to put these ideas on a bit firmer ground. So we used here a method called continuous flash suppression. And in this method, what happens is we show to one eye, we show an image which gradually appears of either a house or a face. So you can see it's a face in this case. And to the other eye, we show a randomly changing pattern of squares, which starts off very high contrast and then decreases in contrast. We use a stereoscope, so both of these images are combined. What happens then is the person starts off by seeing the randomly changing squares, and then at some point they see the image of either the house or the face. The critical thing we do is we lead people to expect to see a house or a face by just putting up the word. And then we measure how long it takes for them to actually see the image. And what we find over a number of different experiments is that when you expect to see a face, you will see that face faster and more accurately. So we see what we expect more rapidly and more accurately than what we don't expect in this study. And so generalizing from that, you could say, we're used to saying, I'll believe it when I see it. It's in fact the other way around. You could say, I'll see it when I believe it. So it's not lo creeré cuando lo vea, pero lo veré cuando lo crea. And these beliefs and expectations are not things we're typically conscious of having. They're things encoded in the structure and the dynamics of the brain and go all the way from beliefs about shadows to implicit beliefs arising from our social and our cultural environments. And the idea of predictive perception, then, can also help us understand in unusual situations where some people experience things that other people don't. And this is typically where we use the word hallucination, when there's a disagreement about what's actually out there. And the basic idea here is that hallucinations happen when when perceptual predictions are too strong. So they overwhelm the sensory data so that you start to see things that other people don't. You see what you expect even more than normal. So this is an example. This is at the campus of my university, of Sussex University, on a Tuesday afternoon. And what we've done here is we've taken a panoramic movie of campus and we've processed it through an algorithm based on a thing called Google Deep Dream to simulate what would happen if the brain had very strong perceptual predictions to see dogs everywhere. So the campus here becomes a kind of a psychedelic playground, and you can see the effects are very strange. There are a few too many dogs compared to normal. And this illustrates, we can take this very loosely as a model of overly strong perceptual predictions of the sort that might happen perhaps in psychosis, but perhaps more obviously in things like the psychedelic state. So let's think about this for a moment. If hallucinations are a kind of uncontrolled uncontrolled hallucination where our perceptual predictions are not reined in by sensory signals from the world, then normal perception, right here and right now, is also a kind of hallucination, but it's a controlled hallucination in which our predictions are always restrained and tested against the court of reality. So there's a descontrolado percepción y un controlado percepción. And taking this even further, you could say that we're all hallucinating all the time. It's just that when we agree about our hallucinations, that's what we call reality. That's what we decide is the real world. There's a consensus to it. And here again, actually, Francisco Varela, I think, said something very similar back in 1975, thinking about who we are as a species, and what we essentially share is our capacity for constructing a reality. So here's my first take-home for this talk. What we consciously experience is just the brain's best guess of its sensory input, la mejor suposición del cerebro de las causas de sus señales sensoriales. The brain's best guess of the causes of sensory inputs. Now, in the second part of the talk, I'm going to tell you that this also applies to your experience of being you. It also applies to the experience of being a self. And this seems a bit weird, right? Because I can show you all these visual illusions that might deceive your eyes, but how could you be deceived about what it is to be you? For most of us, the experience of being a person is so familiar, so unified, and so continuous that it's very easy to take it for granted. But we shouldn't take it for granted. And many experiments show, and many psychiatrists and neurologists know very well, that the experience of being a self can come apart in all sorts of ways. And this shows that the experience of being a person is also a fragile construction of the brain, an experience which, like all others, requires explanation. I mean, there are many different aspects to being a self. It's not just one thing. There's the bodily self, the experience of having a particular body and of being a body. There's the experience of perceiving the world from a first-person perspective. There are experiences of intending to do things, of volition. When people talk about free will, this is often what they're talking about, these experiences. And finally, there's the experience of being a continuous and distinctive person over time, built from a rich set of memories and social interactions. And all these ideas, all these aspects of selfhood can come apart in different ways. And the philosopher David Hume talked about this very nicely many years ago. But I'm going to return today to the bodily self. How does the brain generate the experience of identifying with a particular object in the world that is its body? How does it decide what in the world is part of the body and what isn't? Well, just the same principles apply. The brain makes its best guess about what is the body and what is not. And there's a beautiful experiment which illustrates this. And unlike most experiments in neuroscience, this is one you can try at home. All you need is a fake hand, and I'm sure you all have fake hands at home, and a couple of paintbrushes. In the rubber hand illusion, what happens is a person here wearing the blue, their real hand is hidden from sight, and a fake rubber hand is placed in front of them. Then the experimenter starts stroking the fake hand and the rubber hand in time with each other. And after a while, for most people, this generates the slightly weird impression that the fake hand becomes somehow part of their body. And the idea is that seeing touch and feeling touch on a fake hand that looks like a real hand and is roughly where your hand would normally be, is enough evidence for the brain to make its best guess. That the fake hand is part of the body, and that's the best way to test it. You threaten the fake hand and look for all these effects. Now, I can't resist showing you one of the studies we're doing very recently at Sussex, at my university. We've become very interested in how people differ in having this experience, whether they really experience the hand as their own or whether they remain ambiguous about it. So we undertook what we think is the world's largest rubber hand experiment, where we did this experiment on 400 students in September. And what we find here, it's still in progress, but what we're finding is not everybody experiences this in the same way. The larger point is you can extend the same principle of the rubber hand illusion to the whole body. For instance, by having two people wearing headsets with cameras on, and then swapping the visual feed. If they shake hands with each other, and this provides the critical multi-sensory stimulation, you give people the weird experience of being in somebody else's body, shaking hands with yourself. This is called the body swap illusion. We set this up in a science festival in Brighton, where I lived last year. And there's an important general lesson to all this, and the lesson is that when people report things, you hear reports of things like out-of-body experiences, where people feel that they're floating up to the ceiling and they're seeing themselves from above or somewhere else. We should take very seriously that they have the experiences that they say they have, even while remaining skeptical about what they conclude from these experiences. If you have an out-of-body experience, it doesn't mean that your soul or whatever, whatever your non-material consciousness is, because there isn't any, doesn't mean that that's left your body and has gone floating around. It just means that your brain has reached an unusual best guess about where your first-person perspective is located. So here's the what it seems like picture again, with the world delivering sensory input to the self, which is read out by the self, to form perceptions of this external world. That's what it seems like. Now, what I think is going on is quite different. It's not the self that does the perceiving. Rather, the self itself is a perception. It's another convenient fiction generated by the brain. So here's a second Copernican inversion, if you like. The first was to think that instead of perception being a process of reading out sensory signals that come from the world, it's really an active construction that's reined in by these sensory signals. And the second is to think it's not the self that does the perceiving. Not that the world is delivering these perceptions to the self. The self is another perception. Now, this, I think, changes quite interestingly how we think about the self. If we go right back to the philosopher Descartes, he's famous for saying, I think, therefore I am. Yo cogito, luego existo. So I'd like to just change that a little bit lightheartedly to say, it's rather, I predict myself, therefore I am. Yo predicto, luego existo. So that's the second take-home message. Now, in this short time that I have left, I want to take you a little bit further down a rabbit hole, and just to give you an idea of how far we're pushing this idea of the brain as a prediction machine. What else about human experience can we explain this way? One very important aspect is what we call interoception. This is not introspection, thinking about your thoughts. This is interoception. Interoception is when we normally think of sensation in terms of the 5 classical senses, hearing, vision, smell, touch, taste. But in fact, a large part of real estate in the brain is devoted to sensory signals coming from deep within the body that are telling the brain about how the body is doing, what the heart rate is like, what blood pressure levels are like, how the gut is doing. Collectively, these signals are called interoceptive signals. And they're critically important for the brain because if you think about it, what are brains for? Brains aren't for playing chess. Brains aren't even for figuring out what's out there in the world. Fundamentally, they're for keeping the organism alive. So perception, regulation, control of the physiology of the body, that's the fundamental goal of the brain. Everything else derives and follows from that. This is another version of the rubber hand illusion that we did at Sussex. And here we use virtual reality to give people a virtual hand which would flash to red and back in time or out of time with your heartbeat. And what we found in this one experiment is that when the virtual hand is flashing in time with your heartbeat, you feel a stronger sense that it's part of your body. So this is just one study which shows that our experience of what our body is depends on signals coming not only from the outside world, but also from deep within the body. This is what it looks like in practice. It's a bit hard to see, but it's pretty old school VR as well now. But that hand is flashing to red and back, and we're measuring the person's heartbeat as well. So this brings us back to Descartes one more time. Now, another thing that Descartes argued was that our nature as living beings wasn't really important for our conscious minds. That what made humans special, what made humans distinctive, was our ability to think rationally, was this rational aspect of our minds. And he argued that other animals, non-humans, didn't have that, even though they were alive. For Descartes, other animals were merely beast machines, without consciousness, without awareness, without mind, certainly without anything that warranted ethical status. Now, I think it's rather the other way around, that we have conscious selves and we experience conscious selfhood because of, and not in spite of, the fact that we are living animals, because perception is all about regulation and control of the body. That's where it all begins. There's a strong continuity between life and mind. So this is what I like to think of the beast machine idea for consciousness. We're conscious because of our physiological nature. And this reminds me a lot of science in Chile as well. The other thing that inspired me greatly as a PhD student was work by Varela, but also Humberto Maturana, who talked a lot about concepts like autopoiesis, very strongly emphasizing the connection between life and mind. And this is what's reappearing here in this view. So I'm going to wrap up in a minute, but I just want to tell you two other aspects of self which we're working on. The first is volition and agency. Now, free will is a very controversial thing to talk about. Do we have it? Do we not have it? Well, what seems to be the case is when I make a voluntary action, like raising my hand, I experience a conscious urge to do that. I experience that's a voluntary thing I'm doing. And it's tempting to think that that conscious experience is what causes the action to happen. That's how it seems. But what I think is going on is actually rather different. That experiences of volition are also constructions of the brain. They're also different kinds of perceptions that are the consequence, not the cause, of voluntary actions. And again, we can use virtual reality to try to investigate some of these things. What we do here in this project is we give, again, people virtual hands, and they can make voluntary actions. The key thing here is that these virtual hands sometimes make voluntary actions that the person themselves did not, in fact, make. So we can begin to figure out what the conditions are when people experience an action as their own or as not their own. And finally, the last aspect I want to touch on is time. Now, time for me is particularly interesting because all our experiences unfold in time. We experience the flow of time. We experience durations as lasting for a little bit, for various periods. And time is also as mysterious in physics as it is in neuroscience and psychology, because one of the things in neuroscience, if you think about it, we don't have time sensors in the brain. Now, we have photoreceptors in our eyes, we have hair cells in our ears, but there's nothing in the brain that detects time. We might have a circadian clock, which is roughly 24 hours, but besides that, there's no clock in there. There's no little stopwatch inside my head. So the experience of time has to be a kind of construction, another kind of inference. And with my colleague Warwick Roseboom, we've been working on some ideas that show how the experience of time can be an inference, a best guess based on the rate of change of other kinds of perceptions, in this case, vision. So we show people lots of movies. This is a cow near my university as well. And what we show with the computational models, we can predict how humans experience time based purely, in this case, on visual information. And the larger point here is that it's not just objects like, is it a face, is it a house, is it a body, that is brought within this story of our experience as a controlled hallucination. It's all aspects of the way we perceive the world, how our space is structured, and how things unfold and evolve over time too. So with that, let me bring things together and finish. How things seem is not how they are. Como parecen las cosas no es como son. We started with vision, and with the idea, we started with vision and with the idea that our vivid experience of a world full of objects, people, and places is not a direct window onto an objective reality. It's the result of the brain's continual efforts to anticipate its own sensory flow. And then this also applies to the self. The experience of being you, or being me, is not the thing that does the perceiving, it is itself another perception. And other aspects of our conscious lives, like the flow of time and the experience of will, also emerge as different aspects of the way the brain is always trying to anticipate its own sensory flow. So altogether, our experiences of the world around us and of ourselves are kinds of controlled hallucinations that are designed by evolution to keep us alive in these worlds full of danger and opportunity. And I'll finish by asking, what does this mean for us, for who we want to be as a species, the theme of this Congreso, ¿Qué especie queremos ser? Well, one of the ways to approach it, if you want to understand who we want to be as a species, we need to understand who we are as a species already. Only then can we figure out what we want to be in the future. And one important part of the story I've been telling you for this is that we know we're all different, but I think we all experience the world differently as well. Our personal histories are different, our memories are different, so our perceptual best guesses are always going to be different too. We each inhabit our own distinctive inner universes and perhaps sometimes overestimate the degree to which we experience the same things. And this is particularly true, of course, when we think about mental health and other sorts of mental disease. We can misperceive the world, we can also misperceive ourselves. And now when we begin to understand the mechanism of perception and how they apply to the perception of the self, we can really start to understand what's going on in distressing conditions like depression and schizophrenia in terms of how they have co-opted the mechanisms of perception in different ways. Another important implication of this story that I've already mentioned is that our experiences, especially of the self, are very deeply tied to the fact that we're living organisms. The way we perceive the world is driven by the fact that the mechanisms of perception are designed initially by evolution to regulate and control the body. As the author Anais Nin said, we don't see the world as it is, we see the world as we are. There's a thought here which we're going to hear a lot more about in the next session, about artificial intelligence and the possibility of conscious machines. Now, I don't know whether conscious machines are possible, but I do think that being conscious has more to do with being alive than with being intelligent. We tend to associate consciousness with intelligence because we are intelligent and we are conscious and we're at the top of everything, at the apex of every pyramid. And I think that's a mistaken, a dangerous view. So just making computers smarter is not going to make them sentient. And what it means to be me or you cannot be reduced to or uploaded to an advanced robot, however smart, however sophisticated. And finally, there are other animals with minds too, and inner universes and experiences of selfhood much different from our own. I'm rather thinking about the octopus with most of the brain cells in its limbs compared to the central brain. So for each of us, the experience of being a self is very distinctive, but it's also grounded in biological processes that are shared by many other living creatures. So these really are major shifts in how we understand ourselves and our place in the universe, and I think they should be celebrated because so often in science, just like Copernicus, we're not at the center of the universe, to Darwin, we're related to all other creatures. So these new adventures in neuroscience about what it means to experience being you or me. With a greater understanding, comes a greater sense of wonder and a greater realization that we are part of and not apart from the rest of nature. So this is what I think is a good starting point for who we want to be as a species. We want to be a species that understands at a very deep level that we are part of, that we are fully continuous with the world around us. Thank you very much. Thank you. Muchas gracias.